ASP.NET Core supports two approaches for building web APIs. The first one is called controller-based APIs, and the other one is called minimal APIs. Let's say we want to write some code that handles an HTTP GET request, and based on a given product ID in the request, it returns a product object back. We'll first see how to do this using both approaches, and then understand when we should use which approach. Let's start with the first approach, controller-based APIs. Here, we first go to the program.cs file and add the necessary services to the dependency injection container by calling builder.services.addControllers. Then, towards the end, before calling app.run, we say app.mapControllers. This registers our controllers as endpoints. Next, we have the controllers folder that contains controllers. These are classes that inherit from controller base. So this approach follows object-oriented patterns. The controller class is normally decorated with the API controller attribute that enables certain API-specific behaviors such as making attribute routing a requirement. The controller class is also typically decorated with the route attribute, specifying for instance the controller token. This means requests whose URL starts with the controller name, excluding the controller suffix, are routed to this controller. The controller class contains one or more action methods. For instance, we can have a public action method called get that takes in an ID as a parameter and returns an instance of product. Inside the action method, we can have logic that fetches some data from a database based on the product ID and returns a product. I have hard-coded a product instance for the sake of this example. This action method should handle HTTP GET requests, so we decorate the method with HTTP GET attribute, and we want the product ID to come from the route, so inside the HTTP GET attribute, we specify the route template within curly braces ID. Now, when an HTTP GET request is sent to the URL /products/1, where 1 is the dynamic value for the product ID, it ultimately executes our action method and we get a product object back. So this approach for building web APIs involves traditional scaffolding with controllers and a lot of boilerplate code. Let's now consider the other approach, which is minimal APIs. Here, everything is typically defined in the program.cs file itself, though they can also be organized into extension methods or separate files. We don't have to say builder.services.addControllers because we're not using that approach, and we also don't need to specify app.mapControllers. Instead, what we do is we fluently declare API endpoints. So we say app.mapGet /products/ within curly braces ID. Then we pass in a lambda expression. This takes in an ID as a parameter and returns a product instance. And that's it. No controllers, no traditional scaffolding, and much less boilerplate code in minimal APIs. Now, which approach should we choose? Use the controller-based approach when we are building a large application that contains complex business logic, or when the team is already familiar with the MVC architectural pattern, or when we need to use specific MVC features such as model binding extensibility or advanced validation features. On the other hand, use minimal APIs when we are building a small or lightweight API and we want a simpler approach with less code and configuration. Also, minimal APIs have better performance because they have less overhead compared to controller-based APIs. And since minimal APIs have less framework overhead, they're often a good fit for lightweight microservices and small backend services. Another advantage of minimal APIs is how dependency injection works. In a controller-based API, services are typically injected in the controller's constructor and stored in private fields. In contrast with minimal APIs, dependencies can be injected directly into the endpoint handler's parameters. This keeps the code concise, and each endpoint explicitly declares only the services it actually needs. Note that the underlying dependency injection system is the same in both approaches, only the way you consume those services differs.